Hello, Sauce here. You're not alone if you find factoring challenging. It's challenging when you first learn it. It's challenging all the way up through calculus and beyond. This lesson is going to provide some examples of factoring. It comes after the lesson on factored form. Let's take a look at some examples. This is a mathematical expression 8 plus 12x. It's the sum of two terms. We could call this just in distributed form, but we might be given the instruction or the direction to factor. That means that we want to change this expression and show it as the product of factors instead of the sum of terms. So how do we do that? Well, I'm going to think of dividing these two groups. I want to find a number or a variable that can divide the 8 and the 12x evenly. With some thought, I know that I can divide 8 and 12x by 2. So I'm going to factor out the 2. If I know that I'm going to factor out a 2, I can begin to show the factored form as the factor 2, which is multiplying a group that I have yet to finish. So how do I finish? What do I put in the parentheses? The parentheses are going to contain what happens to these terms when they've been divided by 2. I've factored out a 2 and put it here, so now I want to show it as multiplying. What's left of the 8 when I divide it by 2 is 4. And what's left of 12x when I divide it by 2, I have a 6x. And it's positive because it started as a positive 12x term. Now, I can tell if I'm correct, and I've made a good choice in what I've factored out, and I am correct in what I have left of these terms after I divide, if I can go backwards, distribute the 2, and make it what I started with. I can check quickly that 2 times 4 is 8, and 2 times 6x is 12x. So I'm correct so far, but I'm not finished. I'm not finished completing my factored form because there remains something that divides both the 4 and the 6x. I can factor further. With some investigation, I come to understand that a 2 divides 4 and 2 also divides 6x. So that is another 2 that I'm going to factor out. I'm going to begin to show the next step by drawing the same 2 that I factored out previously, but I'm deciding to factor out an additional 2. That's 2 again. And I have parentheses for what's left of my terms after I divide each term by what I have just factored out. I've just factored out another 2, so what remains of the 4? 4 divided by 2 is 2. 6x divided by 2 is 3x, and it's still positive. Now I can clean this up one step further because these 2's, which are factors, can be multiplied to create the single factor 4. 2 times 2 is 4, and what's in parentheses did not change in this step of work. I'm finished if I can't factor anything else out of what is inside the parentheses. And if I think about it a while, I will not come up with anything that divides 2 and 3x evenly. I've finished factoring, and this is the factored form as far as it can be taken. In this next example, I'm going to go a little faster. It's going to be a little more sophisticated. I have the mathematical expression 3x minus 3xy. And if I'm asked to factor this, then I'm thinking, what is going to divide these two terms evenly? I can immediately see that a 3 is a number in both terms. I can factor out that 3. I place it outside the parentheses and show it as multiplication now. What's left of the 3x when I factor a 3 out? The x's. What is left of 3xy after I factor a 3 out? xy. And the term is negative. Am I finished factoring? I'm not. I can see that my 2 terms inside the parentheses both have an x in them, so I can factor the x out. That means that I'm going to join an x with the 3 that's already there. What remains of the term x when I factor an x out? Well, I have to think, I'll know that if I take the x and I divide by x. X divided by x is 1. It's something over itself. What remains of the xy term, which is negative? When I divide this by x, the y will remain, and it's still negative. Am I completely factored? Well, there's nothing else that will divide 1 and y evenly. So I'm finished factoring what's inside the parentheses. I can check my work if I distribute. If I go backwards, if I distribute the 3x, meaning I multiply 3x times 1, it will recreate what I started with, 3x. And 3x times negative y recreates the negative 3xy term. So I've checked. This is the completed factored form. One more example. This is going to be a little more sophisticated. 15x minus 5x squared plus 35x. I've got 3 terms this time. So if I'm going to factor anything out, then what I factor out must divide all 3 terms evenly. With a little investigation, I can see that every term has an x in it, so I know that I can factor out an x. But I also see that a 5 will divide these 3 terms evenly as well. It's possible to factor out 2 things at once. I'm going to factor out 5x, a 5 and an x at the same time. So what remains out of these terms when I divide by 5x, I will put inside the parentheses. What is 15x divided by 5x? The x's cancel out, and the 15 divided by 5 becomes 3. What remains of the 5x squared? When I divide by 5x, the 5's will cancel out, and remember, x squared means x times itself. So factoring out an x cancels only one of the 2 in the x squared. So what remains is the other x. And the term is negative. Last one, what is 35x divided by x? 35x divided by 5x. The x's will cancel out. And 35 divided by 5 is 7. And this term is positive. Let's take a look at what remains. I have inside parentheses a 3 and an x and a 7. There's nothing that can be factored out. However, I could combine the 3 and the 7 because they're common terms, they're just numbers, there's no variable component. So I can group the positive 3 and the positive 7 to be 10. The minus x is still there. And I have my 5x outside that's multiplying. This is in factored form. And you might notice that I could have, from the very beginning, taken the step to combine these 2 terms because they're like terms. I could have started with that, but for the purposes of showing an example where I can start with 3 terms and factor out something from all 3 terms, I kept it like that.